mean that space is litter-free. There is trash in space that's causing serious trouble for the space program. It's known as orbital debris, and at NASA's Johnson Space Center there are 25 people dedicated to tracking it. Scientists at Johnson systematically monitor and catalog pieces of space junk. Based on this information, rocket launches will be scheduled to avoid hitting any of the 9,000 pieces of orbiting metal that range from 10 centimeters to the size of an abandoned rocket.
What you're seeing here is a computer animation of the 9,000 objects that are tracked by the Department of Defense. You're starting out fairly far away, looking down over the North Pole. This concentration through here is the geosynchronous belt. That's the altitude where the time it takes the object to go around its orbit is 24 hours. So it's with the Earth. And then as you get lower into the low altitude stuff, this is where currently the largest concentration of debris is. The potential for creating a lot of debris comes from the big payloads and rocket bodies that are up there. The upper stage of a rocket is typically left in orbit. Residual fuel has been left in those rocket bodies. And as time goes on and you go through the Earth's shadow back into the sun, there's thermal stress on the rocket. You'll mix the fuel with the oxidizer and you have an instant explosion.
Rockets can usually avoid the tracked objects. It's the smaller, untrackable debris that is causing most of the damage.
We look at sizes that can seriously damage a space shuttle or a space station. And those sizes, we're looking at about 1 centimeter in diameter and larger. That's about the size that we're talking about. That size could puncture the pressurized vessel in the space station, for instance.
NASA put into orbit pairs of spheres of 2, 4, and 6 centimeters to calibrate their telescopes. These spheres are traveling at the same rate as orbital debris, about 7 kilometers a second. At that speed, a 1 centimeter piece of metal has the same energy as a small automobile traveling at 60 miles per hour.
What we're showing here is an example of a test shot that was actually shot with a hypervelocity gun that NASA operates. This was a 1 centimeter sphere that was shot at 7 kilometers per second. And this is an example of the kind of damage that this can do. This is an aluminum block about 1.5 inches thick. It's a hypervelocity impact, so there's actually a shock wave that travels through the material. And the energy actually partially melts the aluminum here, and you'll actually blow out the back side.